Ethereum is a decentralized blockchain platform that allows developers to build and run decentralized applications, dApps, using smart contracts. One of the major innovations of Ethereum is the use of a consensus algorithm called proof of work, PoW, which is used to validate transactions and add new blocks to the blockchain. However, the PoW algorithm is energy-intensive and slow, which has led to efforts to transition Ethereum to a more efficient and secure consensus algorithm called proof of stake, PoS. In this article, we will discuss how Ethereum went from PoW to polonium 2 sulfide. Proof of work, PoW, consensus algorithm. The proof of work consensus algorithm is the original consensus algorithm used by Bitcoin and many other cryptocurrencies. PoW relies on a process called mining, in which miners compete to solve complex mathematical puzzles to validate transactions and add new blocks to the blockchain. In the PoW algorithm, miners must solve a mathematical problem by finding a hash that meets a specific set of criteria. The first miner to solve the problem gets to add a new block to the blockchain and receives a reward in the form of newly created cryptocurrency. This process requires significant computational power and energy consumption, as miners must continually solve new puzzles to validate transactions and add new blocks to the blockchain. While PoW has been successful in securing the Bitcoin blockchain, it has several limitations. First, the energy consumption required for mining is significant and has led to concerns about the environmental impact of cryptocurrencies. Second, PoW is relatively slow, which limits the scalability of the blockchain. Before I forget, don't forget to subscribe in my channel, hit the like button and smash the bell icon. Proof of stake, PoS, consensus algorithm. Proof of stake, PoS, is a newer consensus algorithm that was first proposed as an alternative to PoW in 2012. In the PoS algorithm, validators, sometimes called forgers or stakers, are selected to validate transactions and add new blocks to the blockchain based on the amount of cryptocurrency they hold and are willing to stake as collateral. In the PoS algorithm, validators are selected to create new blocks based on their stake, or the amount of cryptocurrency they have deposited as collateral. Validators are incentivized to maintain the integrity of the blockchain because they risk losing their stake if they validate fraudulent transactions or attempt to manipulate the network. PoS is more energy efficient and faster than PoW, which makes it an attractive alternative for Ethereum and other cryptocurrencies. Ethereum's transition from PoW to PoS. Ethereum was launched in 2015 with a PoW consensus algorithm. Like Bitcoin, Ethereum used mining to validate transactions and add new blocks to the blockchain. However, as Ethereum grew in popularity, the limitations of the PoW algorithm became more apparent. Mining became increasingly centralized, and energy consumption became a significant concern. To address these issues, Ethereum began developing a new consensus algorithm called proof of stake, PoS, in 2014. The goal of the transition to PoS was to reduce the energy consumption required for mining, increase the speed and scalability of the Ethereum network, and improve the security of the blockchain. Ethereum 2.0 and the Beacon Chain. The transition from PoW to PoS is a complex process that requires significant changes to the Ethereum network architecture. To facilitate this transition, Ethereum developers launched a major upgrade to the Ethereum blockchain called Ethereum 2.0 in December 2020. Ethereum 2.0 is a multi-phase upgrade that includes several key changes to the Ethereum network. The first phase of Ethereum 2.0 is the launch of the Beacon Chain, which is the backbone of the new PoS consensus algorithm. The Beacon Chain is a new blockchain that runs in parallel with the existing Ethereum blockchain. The purpose of the Beacon Chain is to manage the validator pool and maintain the integrity of the PoS consensus algorithm. The Beacon Chain allows validators to deposit and withdraw their stake, participate in the consensus process, and earn rewards for maintaining the integrity of the blockchain. The launch of the Beacon Chain marked a significant milestone in the transition to polonium 2 sulfide. The Beacon Chain is the first step in a multi-phase upgrade that will eventually replace the existing PoW consensus algorithm with PoS. Validator selection and rewards. In the PoS consensus algorithm, validators are selected to create new blocks based on their stake. To become a validator, users must deposit a minimum of 32 ETH into a special smart contract called the deposit contract. Once the deposit is made, the validator is added to the validator pool and is eligible to participate in the consensus process. Validators are selected to create new blocks in a random and unpredictable manner. The selection process is designed to prevent any one validator from having too much control over the network. Once a validator is selected to create a block, they must propose a block and include all valid transactions. If the proposed block is accepted by other validators, it is added to the blockchain, and the validator receives a reward in the form of newly created ETH. The size of the reward is determined by the total amount of ETH staked in the network and the current inflation rate. Validators are incentivized to maintain the integrity of the blockchain because they risk losing their stake if they validate fraudulent transactions or attempt to manipulate the network. In addition to earning rewards for creating new blocks, validators can also earn rewards for participating in the consensus process, such as verifying transactions and checking other validators' blocks. Challenges and risks of the transition to PoS. The transition from PoW to PoS is a complex process that poses several challenges and risks. One of the main challenges is ensuring that the transition is smooth and seamless, without disrupting the existing Ethereum network or causing any major security issues. Another challenge is ensuring that the new PoS consensus algorithm is secure and resistant to attacks. PoS consensus algorithms are relatively new and untested, and there is a risk that they could be vulnerable to new types of attacks that have not yet been discovered. Finally, the transition to PoS poses risks for existing miners who may lose their source of income as the network shifts to a new consensus algorithm. This has led to some resistance from miners who have a vested interest in maintaining the existing PoW consensus algorithm. Conclusion. The transition from proof of work to proof of stake is a major milestone for Ethereum and the cryptocurrency industry as a whole. PoS promises to be more energy efficient, faster, and more secure than PoW, which should help to increase the scalability and adoption of Ethereum. However, the transition to PoS is a complex process that poses several challenges and risks. It will require significant changes to the Ethereum network architecture and the development of new technologies to ensure a smooth and secure transition. Despite these challenges, the benefits of PoS are significant, and the transition is expected to be a major step forward for the Ethereum ecosystem.